In Chapter 3, we began to look at how the derivative can tell us something about the graph of a function. And the first way we're going to look at that is by looking at what we call extrema on an interval. If you recall, an extremum is either a minimum or a maximum value on a graph. So let's start with some definitions. If we have a function f that is defined on some interval I that contains the value c, then f of c is the minimum of f on I when f of c is less than or equal to f of x for every x in I. Now that's a lot of words, but all that's saying is that f of c has to be smaller than every other f of x in that interval. That makes sense. Minimum is the smallest value. Likewise, f of c is the maximum if f of c is greater than f of x for every, or equal to, greater than or equal to, if f of x for every x in that interval. Now, when we are looking at a closed interval, as you can see in this picture, we're looking at the closed interval from 1 to 4. It's closed because we do have the endpoints b and c. When we're looking at a closed interval, extrema on that interval are referred to as absolute or global extrema. I will usually use absolute, but you might see both. An extremum that occurs at an endpoint of an interval is called an endpoint extremum. So you can see that b is the absolute maximum on this interval, and a is the absolute minimum. And furthermore, because b is an endpoint, it's an endpoint extremum. Notice that c is an endpoint, but it is neither a minimum or a maximum, so it's just an endpoint. Now, we have what is called the extreme value theorem. And all this tells us is that if a function is continuous from some a to some b, including the endpoints, then that function is going to have both a minimum and a maximum value on the interval. If you notice, the graph to the right shows a function for which the extreme value theorem, or EVT, applies. We have both a maximum at b and a minimum at a. For the bottom graph, the extreme value theorem does not apply because this function is not continuous on that interval. It has a vertical asymptote at 1.5. One more definition we want to look at is the definition of a relative minimum or maximum, or in general, a relative extremum. And what we say is that a point c, f of c is a relative extremum of a function if we can define an open interval on which it is an extremum. That means that endpoint extrema cannot be relative extrema because endpoints are not included in open intervals. But as you notice, the yellow bands on this graph define open intervals, one on which a is the minimum value and another on which b is the maximum value. And those open intervals, those relative extrema, last year we referred to those as turning points because usually that's a point where the graph turns around. Now, we would like to locate these relative extrema, and the way we do that is by finding what we call critical points. A critical point is any point at which the function is defined, but the derivative is either 0 or undefined. So we see 3 critical points on this graph to the right. 2 of them have the derivative equal to 0. When x is 0 and when x is 4, you see that the tangent line is horizontal, which is how we recognize the derivative to be 0. And we notice that we also have this one place where the derivative is undefined at point b, when x equals 2. Notice that b would be a relative maximum and c would be a relative minimum, but a is neither. Not all critical points are extrema. All relative extrema must occur at critical points, but not all critical points are extrema. Okay. Now, when we want to locate the extrema on an interval, we use what is called the candidate's test. It's called the candidates test because we list all the possible candidates that could be the minimum or the maximum. And those are either the endpoints or the critical points. So we start by finding all the critical values on the interval. I will give some examples of this in other videos. So we find the critical points by setting the derivative equal to 0 or finding places where the derivative is undefined. Once we have those critical values, however many there are, we make a table with the endpoints and the critical values. We compute the function value for each x value in that table. And once we have all those function values, all we have to do is pick out the least value to be the minimum and the highest value to be the maximum. And that's how we do the candidates test. We have to include the endpoints and we have to include every critical point. I will give some, as I said, I'll give you some examples of locating critical points and extreme values in other videos, but this is the basic information you need about extrema on an interval. Your assignment for this section, first assignment for section 3.1, is on page 167, and you see the assignment numbers listed here.